All right. Yeah. So I don't know. We'll see what happens with some of that changes.
Yeah. And if it changes, it changes. If not, we'll keep having 2-person meetings, I guess.
Yeah. I think I met with her. Was it last week or was it the week before? I can't remember. But it seems like it's been, I don't know, it's been crazy. The other guy, Ethan or whatever his name, he's got to be getting a million emails. I would think after a while, at least I'd say, stop sending the emails if I wasn't in the class.
Yeah, I know. I was thinking the same thing. Man, what does he fill out? Like, if he's still in the class, what does he fill out for, like, the group report or whatever,
Yeah.
Mm-hmm.
All right. Well, I guess let's go ahead and start with a prayer.
Yeah, that'd be great.
All right, I'll go ahead and say it.
Okay.
Our dear Heavenly Father, we're thankful for this day, and we're thankful for the chance that we have to meet together tonight. We also will be able to have Thy guidance as we work through this class, and we'll be able to have inspiration and have our understanding opened up, and be able to do well in the class. And we say these things in the name of Jesus Christ. Amen.
Amen.
All right. Go ahead.
Go ahead.
I was just curious how it's going for you. Are you still cruising right along?
Yeah, so I took calculus before. I took it in high school.
Yeah.
And so it's just trying to remember the little things.
Did you do integral calculus also?
Yeah, I took BC Calc. It's an AP class.
Mm-hmm.
But I took it in 2010, and so because it was so long ago, you can't transfer it anymore. So I figured I could take it again after my mission to refresh. And so I'm having some things that I don't remember as much, but there are other things that I just get pretty easy.
Yeah. Well, some of it, like today's, actually first, I've been working. No, it was actually today's homework. So I try to stay a day ahead, but right now I'm not. And I got kind of behind a little bit a couple days ago because it was just every problem was taking me like an hour. And and then I'd get it wrong sometimes.
Really?
Yeah.
I know. That's why I'm super grateful for to help me solve this problem.
Me too. Some of them don't have that though.
That's true. I found that out the other day when there was one I didn't know how to do, and I was like, "What the heck?"
So. Yeah, I took differential calculus back in when was it? It was over 10 years ago.
Yeah.
In fact, it was probably close to 15 years ago. And man, but I did not do any integral calculus.
Really?
Yeah. So I think we kind of touched on kind of at the end of the class here. There's a few antiderivatives, kind of to get you thinking about it, and
that was about the extent of it.
Yeah. My wife thinks it's funny though when I start talking about integrals because she thinks it sounds like I'm saying integral.
Oh.
Imagining this superhero integral.
That's funny.
I think that should be made into one of the math jokes of the week or something.
Yeah, the integral.
So it seems like, and I don't know why, but where did my pencil go? Jeez. That's weird. Oh, there it is. It seems like what I am struggling with more than anything is, and I don't know why, it's like I said, the definite integrals.
Okay.
And when I go back and check it, it looks like I have done the gotten the indefinite. I go through and do the indefinite integral first, and it seems like I get that part, But then when I try to plug in the values and calculate it all out, I don't know what I'm doing wrong.
Okay.
Or if you're trying to find the area between curves, I struggle with that too, which is a lot the same thing.
Mm-hmm.
Yeah.
Yeah. Area between curves, I have to graph every single one, because if I don't graph it, I just don't understand it.
Yeah, it's hard. Even after I graph it, sometimes I look at it and I'm like, okay, what's going on here?
Mm-hmm.
Especially.
There's one.
Go ahead.
Go ahead.
I was just gonna say, especially ones, a couple of the last ones we did where you took one curve, figured out the whole area underneath it, and then subtracted another area, and
yeah, that was weird for me. I was like, okay, like I would have done it completely different. Like I did it as the integral underneath the first curve and then the integral underneath the second one. Mm-hmm. But when I did that, I got it wrong. But then when I did it the way they wanted it, it was right, and it was a different answer. So it's like,
yeah, I get so confused with that. That's what I'm really struggling with. I think right there, that and getting sleep, because I've been doing this stuff so much.
I know, right?
Oh, did some of the problems take you as long as they take me?
Some of them, like some nights, I'm usually done with, because I get home from work at 5, and I usually start around 6:30 or 7 on my homework, and I'm usually done around 9 o'clock. But some nights I'm up till 9:30, probably.
Yeah.
Mm-hmm.
I've had much later nights than that.
Oh man.
So I guess I'm just a little slower at it. But I need to get right. I'm trying to find a good example. Like, let's see, what is?
Yeah, let's find one that we can do together, and we can do that one, and then maybe one more, and then we'll call it a day so we can finish our homework.
Okay, sounds good. I'm trying to find. Well, there's something I struggled with a little bit.
Okay.
Let's see. Oh, I wish I should have had one ready already, but
that's okay.
The problem is, I'm afraid try these will take so long to do.
We can do just like a simple one if you want, and then we can try an example one.
Okay, do you know of a good simple one to?
Sure. So let's do an integral from 0 to pi of the cosine of 2x dx.
Okay, sounds good.
That's pretty simple, right? And we can just work on that.
Yeah.
So let's start by graphing it, you think?
Sure.
Just so we can, because I'm trying to remember if there's a part of that that goes under the curve on that interval, but I don't think there is.
Goes under the curve? Like
goes under the x-axis?
Oh, on that range of 0 to pi?
Yeah. So when the cosine of 2x, when x is equal to 0, the cosine of 2.
It would be 2, right?
Yeah. Oh, wait, no. The cosine of 0 would be 1. The x value is 1. Right?
But we have 2x.
Wait, yeah, but the cosine of 0, 2 times 0 is 0.
It's still 0.
And then the cosine of 0 is 1.
Yeah, so you're right. It's still 1.
Okay. I was like, what the heck?
Yeah. Okay.
Uh-huh. And then the cosine at pi halves, or pi fourths, would be the square root of 2 over 2. And so the cosine of pi is 0, so it doesn't cross the x-axis, so that makes it easy. So like here's my graph.
Cosine of.
Like that shaded part.
Okay. Yeah.
In the area of. That
Yeah,
makes sense?
because 2 times. Wait, how does that work? Because if it's pi, if we go to pi over 2,
Uh-huh.
that would be just the cosine of pi.
Oh. So I'm going to put it in my graphing calculator that I use
Sounds good.
just to make sure I've got this right.
No, that's right. Because yeah, no, you're right though. And it would go to the cosine of pi,
Oh,
which would just be 0.
so pi is actually, according to my graphing calculator, is up here. So when I look at this, so pi's further out. That's a full cycle. Makes sense.
Cosine of. So cosine of 2, in this case, if we had pi over 2, it would be 0.
What do you mean?
Because
Oh.
wait, no, it wouldn't.
Mm-mm.
No, because it would be cosine of pi, so it would be -1.
Yeah.
Yeah. Okay. Yeah. So it does actually cross. Well, we could just do to
pi halves, or yeah, pi halves. No.
be pi over 4.
Yeah.
Pi over 4 is actually where it would I think where before it would cross the x-axis. I think that's where it would cross the x-axis is pi over.
All right. Well, let's change it then. Let's do pi over 4.
Sounds good.
Make things
I
easy.
think that's part of what I'm messing up though is when I get confused about when it crosses that when we are doing areas underneath too, and yeah, I don't know.
Yeah, because if we were to go on and solve it from 0 to pi, the answer would be 0, because the amount beneath the x-axis and the amount above are equal.
Mm-hmm.
And so then you have to take that and absolute value it. And it's complicated.
Yeah, and I think that's part of what I'm getting you because you do have. I think if you do, I think sometimes I should be doing an absolute value of part of it, and
or just taking an interval. So on this one, you could take it from pi fourths to whatever that next time it crosses the x-axis is.
Yeah.
And then just times that by 2. And then you would be set. You just have to absolute value and times it by 2. And that would give you that whole interval.
Absolute value it and times it by 2. Why would you times it by 2?
Because so if we were to take just the integral of, sorry, I kind of have been scribbling on it, from here to here underneath the x-axis, that'll give us a negative value for that amount below the x-axis. So if you take the absolute value, that'll make it positive. Yeah. And then you times it by 2, and that will give you these two sides as well. And so that amount. Okay. But okay.
So let's do pi from pi 0 to pi over 4, if I can say it.
Yeah, sounds good.
Okay.
So if we integrate the cosine of 2x, we'd get 1/2 sine of 2x, right?
That sounds right. I always have to think back through it. That's probably what takes me a while. Is I think I kind of have to take the derivative of it to make sure I was right.
Yeah. See, and my mind is very math oriented.
Yeah.
And so some simple equations I can just look at and do without having to like work through steps, because that's just the way my mind works.
Yeah. But that looks right though. So oh, whoops.
That's evaluated from 0 to pi force.
Okay, so we would just go. So we would just say, if I understand it right, we just take the half of sine of 2 times pi over 4.
Uh-huh.
And this is real simple because there's only one term.
Yeah.
That makes it a lot easier. I think what I mess up a lot of times is flipping signs around and stuff too. So we just go minus half the sine of 2 times
0.
0.
Mm-hmm. And so the sine at pi halves is 1. So that'd be 1/2. And the sine of 0 is 0, so minus 0. And so our answer is 1/2.
Yeah.
Pretty simple.
That makes sense. Yeah.
Maybe let's do one now between two curves, or maybe even between a curve and a line.
Okay.
If you want.
Sure.
So what if we did just that same cosine of 2x?
Okay.
And the line y is equal to x. And
okay.
Area in between there.
Okay, so we're looking at which portion of that are we looking at here? We're looking at I guess it depends on which one we subtract from which, huh?
Mm-hmm.
So we have something kind of like let's see. Wrote really big. You can see my big writing I've been doing. Something kind of like that.
Exactly like that.
Yeah, and so which area are we doing?
Do you want to do the one in between the y-axis and the above y equals x?
Sure. So.
Ooh, but that might present a problem because we don't know where they. Is there a way to solve when they intersect?
Let's see if we have. So we have cosine of 2x equals
X. Yeah, I don't know how to solve that one. Let's do something simpler. What if we did y is equal to x squared?
Okay, so all right.
Y equals x squared plus 3.
Y equals x squared plus 3.
Uh-huh.
A simple parabola.
Yeah, and then the line y y is equal to 4.
Oh, y is equal to 4.
Yeah, is the other line, and we can find that little bowl shape.
Little tiny piece that's underneath.
Yeah, or that's above, because like to exaggerate the graph, it should look like. Sorry, I'm trying to find it on here. Where is it? Like this.
Yeah, that's what I meant. That little tiny bit that's underneath the
Y equals 4.
Yeah.
Yeah.
Yeah, that's what I got. Basically is not that I need to show it, but that right there, you're just getting that little tiny part.
Yep. And so
okay.
Set them equal to each other, and you get -1 and 1 as the intercepts.
Yeah, you're fast. That fast.
Yeah, I'm pretty.
But okay, yeah. Oh, that's not hard though. Yeah, we just get x squared equals 1, and then yeah. So x equals plus minus 1.
Yeah.
Okay.
And so then we'd change that to the integral from -1 to 1
Yeah.
of 4 x of 4, right?
What's that?
It would be the integral from -1 to 1 of 4 minus x squared plus 3 in parentheses.
Yeah, you do the top one minus the bottom one.
Yeah.
So that makes sense. So yeah, so 4 minus x squared plus 3, which we
Which
can
would
evaluate.
But if
hold on, do we
go ahead.
Oh, so do we subtract those from each other now?
Yeah, you totally can.
I think what I've been doing is taking the finding the integrals and then subtracting the integral from the other one.
Okay. Well,
maybe that's not getting it wrong. I don't know.
You can do it multiple ways. You can subtract them at first, or you can find the area under the curve of under y equals 4, and then find the area of y equals x squared plus 3, and then just subtract them.
Yeah.
But usually in my experience, you want to do like one or the other, and you want to do it either at the beginning or at the very end, because if you try and do it somewhere in the middle, that's where it'll get confusing and you'll lose a bunch of numbers.
I think I think that might be what I've been doing wrong. I think maybe because I've been finding, like what I've been doing is, okay, say find the integral of 4, and then find the integral of x squared plus 3, and then subtract those, one function from the other one.
And that could work. Like, I don't know if that's...
Maybe it does, maybe it doesn't.
And it could work, but for me, it's so much easier to get confused trying to do it like all in the middle.
Yeah. Okay, so we got the integral of -1 to 1 of 4 minus x squared minus 3.
Yep.
And
so then that would be 4x plus 1/3 x cubed minus 3x evaluated from -1 to 1.
Wait, hold on. So you got negative x cubed over 3.
Yep.
Then we got 4x minus 3x. Is that right? Plus x. Is that what you said?
Yeah.
Okay.
It's not what I said, but now I'm looking at it. It does. That's what it is. It's
negative x cubed over 3 plus x.
Yep.
Okay. All right. So now I just need to plug in some values. Whoops.
And what I like to do is I like to keep my values separate. So I'm going to solve for the value of the first, so when the equation is equal to 1. And so that's 2/3 is that first one. I'm going to solve it all the way down to the 2/3.
Okay.
And then I'm going to do the same thing for the other side and then solve it all the way down to one number.
Yeah.
And then subtract them, because then it's easier to not get confused with terms and like, do I carry this negative or drop this negative?
Okay. Well, maybe that, you know what? That's true. And that's where I get so confused so much of the time is you're subtracting a negative from a negative that has a negative value in one of the terms. It's like,
Exactly.
okay, where am I? Yeah, and I've done it that way sometimes. I think that's the way I should do it more often. Yeah, so we just have -1/3 plus 3. Oh yeah. Okay. I see what you said. You're faster than I am. That's the other thing too. I can get the answers, but it takes me longer.
Oh, sorry about
I just finally got 2/3. Maybe it's because I'm talking too much too. I don't know.
Yeah, and just the way my brain is wired, I'm a very engineering minded person, and so it just kind of all makes sense to me.
Yeah.
So let me know what you get when you get those two equations down. And I just checked it too with the computer, make sure it was right.
Yeah, I think I'm almost there.
You're good.
Okay, hopefully I got that right. So I got 2/3 for the first one and negative 2/3 for the second one. Did I do that right?
Yeah, that's right.
Okay.
But when you subtract a negative,
It's gonna add to it. So we're gonna have 4/3.
Yep.
That's the answer. Okay.
Mhm.
All right, that sounds good. I think that at least with doing it that way, it might make it a lot simpler for me.
Yeah.
Yeah.
And it does for me too. And even sometimes still, like I get them wrong.
Mhm.
But as long as I make sure like I'm neat with my notes and what I'm doing, it's pretty easy to go back and say, okay, I dropped a negative here. I did that. So.
I'm glad that's easy for you. For me, once I do it, it's looking back and you're just looking at the same mistakes. And it's not, I get it. I find them sometimes.
Yeah,
But a lot of times it's easier for me just to start from scratch and do it again.
exactly.
It depends, because it's easy to look at something and think it looks right. It's almost like looking at reading your own thing you've written up, trying to find spelling errors.
Oh yeah.
It's easy to miss them, because I don't know. I'm actually pretty good at that, but
See, and that's where I lack. Is like I'm terrible at English. I have to.
yeah. I'm actually more mathematically minded than I am. I'm not. I am not. I'm more technical minded too.
Uh-huh.
So I I understand things. I get things. I just when it comes to actually calculating it out, I think it just takes me a while to look at it and to get it, and my mind wants to go through and double check and triple check and to make sure I didn't make a mistake. And I don't know.
That's
So
good.
it just takes me a little bit of time, but I get there and I understand it usually. So
Exactly. See, and that's all that matters, right? Is that you understand it and you get the right answer. So.
well, in the end, I suppose, but I'd get more sleep if I could do it quick.
That's true. That's really true.
Oh, but yeah, I mean, I actually one of the things I was proud of when I was in trigonometry,
Uh-huh.
way back when, was it in trig? I think it was in trig that I actually did it because everything is based on, it starts off of the Pythagorean theorem.
Yeah.
It's all the proofs, everything started off of that, and so. And I thought about it different times, but I was thinking, man, how do I, we're proving everything based off of this theorem, but how do I know that this theorem is true? And I'd been messing with it, trying to draw things out, just because I do like this, I think about those things, and I kept trying to draw it out, like how do I do this, and nothing would fit together right, nothing made sense. And then finally one day I did it on a piece of graph paper. And I started drawing these triangles going different ways, and it was like, wow, that's it. and I proved the Pythagorean theorem.
That's sweet.
I was pretty proud of that.
Oh, heck yeah, man. Anytime you prove something, you're like, man, I felt good.
Yeah, it was awesome.
That's cool. All right. Well, do you want to do any more, or do you feel comfortable with what we've done tonight?
No, I'm good. I'm good. Thank you so much for your time.
Yeah. Hey, anytime, man. And I'm sorry I kind of have to butt out. I have to get in early to work tomorrow. So.
Yeah, that's just fine. Gotcha. Thanks for sticking around for a little bit, and I guess I'll go ahead and end the broadcast now, and I'll see you Well, I assume I'll see you next week.
I'll be here next week.
Yeah, as long as we don't get swapped around, but I don't think that's what.
No, I think she just sounds like she's combining groups.
Okay, that makes sense.
With another group.
Okay.
Alrighty.
All right. Well, thank you.
Yeah, anytime. We'll see you next week, Justin.
Yeah. See you next week.
And if you